Hello, everyone. Welcome back to our monthly Airbyte AI webinar series, and welcome to everyone who's new. I'm AJ Steers. I'm excited to be here today with AWS Senior Solution Architect Satya Balakrishnan and my colleague Joe Reuter, also from Airbyte. Joe and I make up the Airbyte AI team, focusing on making Airbyte the best go-to data movement tool for all AI use cases. We're excited to be joined by Satya from AWS, who will be explaining the new features and new announcements from reInvent and how you can take advantage of them in your own AWS cloud. Our topic today, end-to-end AI pipelines with Airbyte and AWS. Without further ado, let's dive into it. So here's what we will cover today. We'll kick off with Satya giving an overview of the Bedrock capabilities in AWS, which were launched in reInvent earlier this month. And they're available now for you to incorporate in your own applications. Satya will be walking you through those technologies and other products that can help you make the most of your cloud. And after that, Joe will give you an overview of the latest Airbyte features and getting data into your AI application or any other analytic or operational data pipeline that you might want to build. Airbyte can move data from virtually any source to any destination, which makes it a great complement to AWS Bedrock and the AI toolset we're going to see today. Wrapping up, I'll be giving a demo and a quick tutorial on how you can combine this all together into a custom AI agent with your own data and no external dependencies besides Airbyte and AWS. So with that, I will hand off to Satya.
Thanks, AJ. I just shared my presentation. Give me a thumbs up when you can see it. Cool. Good morning, good afternoon, good evening, everyone, depending on where you're joining us from. My name is Satya Balakrishnan. I'm a Senior Solutions Architect at AWS. And like AJ mentioned, we'll go over a high-level overview of Bedrock and its key features, namely Bedrock agents and knowledge bases. And we'll talk a little bit about vector search and vector search capabilities on AWS. All right, let's talk about Bedrock. So Bedrock is a fully managed service that offers a choice of high-performing foundation models from leading AI companies, along with a broad set of capabilities you need to build generative AI applications. All of this with security, privacy, and responsible AI in mind. Using Bedrock, you can easily experiment with and evaluate top foundation models for your use case. You can privately customize them with your data using techniques like fine-tuning or retrieval augmented generation, like RAG, and build agents that execute tasks with your data. And since Bedrock is serverless, you don't have to manage any infrastructure, and you can securely integrate and deploy generative AI capabilities into your applications and using the AWS services that you may already be using. And like I mentioned earlier, just want to highlight the choice of models here. So if you look at the options, you have foundation models from leading AI companies like Amazon, Anthropic, AI21 Labs, Cohere, Meta, and so on. And the takeaway here is flexibility and model optionality to support a wide variety of use cases. So to equip these foundation models with up-to-date, proprietary, relevant information, companies often use techniques like RAG, which involves fetching data from your data sources, enriching the prompt with that data to deliver more relevant and accurate responses. Knowledge bases for Bedrock is a fully managed RAG capability that allows you to customize foundation model responses with contextual and relevant data. Knowledge bases automates the end-to-end RAG workflow, including ingestion, retrieval, and prompt augmentation, eliminating the need for you to write custom code to integrate data sources and manage queries. You can quickly add a knowledge base by specifying a data source like S3, an embedding model like Amazon Titan, and a destination vector database, like could be a vector engine for OpenSearch Serverless, Pinecone, Redis, to name a few. And all the information retrieved from the knowledge base comes with source citations to improve transparency and reduce hallucinations. Agents for Bedrock plan and execute multi-step tasks using your systems and data sources. So this could be from answering customer questions about your product availability, taking their orders, fulfilling support queries, etc. And with Bedrock, or you can create an agent in a few clicks by selecting a foundation model and providing it access to your systems, knowledge bases, and a few Lambda functions. And so an agent will analyze the user request, automatically call the backend APIs and data sources to fulfill the request. Agents for Bedrock enable you to do all this securely and privately. No need for you to engineer prompts or manage session context or manually connect systems. The agent securely connects to your company data sources through APIs. It converts your data into machine-readable format and augments the user request with relevant information to generate more accurate responses. And you don't have to worry about complex systems integration and infrastructure provisioning. All of this is serverless. As a fully managed service, agents will take care of all of this for you. All right. So let me talk a little bit about vector. Before talking about vector search capabilities on AWS, for those that aren't familiar, just to give a high-level overview of what are vector databases and what is vector search. So a vector database allows you to build, store, search, and manage vector embeddings so that you can perform vector search on top of these embeddings. So you would do this to provide contextually relevant results for your user queries and improve end user experience. So, and vector search is an ability to find similar items or entities based on their numerical representations. And these numerical representations, often referred to as vectors. So vector search requires items or documents to be represented as high-dimensional vectors in the vector space. And each dimension represents a particular feature or an attribute of the item. By representing items as numerical vectors, then it becomes easier to calculate similarities using mathematical formulas like Euclidean distance or cosine similarities and so on. So the main goal of vector search is to efficiently and effectively retrieve items that are similar to a given query item. And with that, those that are not familiar with Amazon OpenSearch service, let me start by saying that OpenSearch itself is an open source software, primarily used for search, analytics, and observability applications. It comprises of three things. It comprises of a search engine, which is OpenSearch itself, a dashboard for visualization, and a suite of plugins that are used for advanced capabilities like alerting, fine-grained access control, vector storage, etc. And Amazon OpenSearch service is a fully managed service that makes it easy for you to deploy, scale, and operate OpenSearch on AWS. So let me explain, vector search and a vector search on OpenSearch with an example. So we're all familiar with the search box interface. And let's say, you wanted to buy a couch. So you go to Amazon.com and you type, let's say, a cozy place to sit by the fire. And if you were to run that search on Amazon.com, you might see items like fire pits, heating pans, home decorations, and so on. Not exactly what you expected. So the problem here is, couch manufacturers probably didn't use the keywords, cozy, place, sit, fire in their product descriptions or product titles. So now if you use an embedding model, a type of model that can encode a large corpus of data into n-dimensional space where each entity is encoded into a vector. So by searching for the vectors nearest to an encoded document, on OpenSearch, you can use the KNN plugin. You can find the most semantically similar documents. So now when you search for a cozy place to sit by the fire in your catalog, you can encode that prompt and use OpenSearch to perform a nearest neighbor query. And that would surface possibly a blue couch with designer arranged photographs in front of a fireplace. And note that Amazon OpenSearch service comes in two flavors. It has a provision mode where you get to manage the infrastructure and a serverless offering. And Vector Engine for OpenSearch serverless introduces a simple, scalable, and high-performing vector storage and search capability. So this new capability makes it easy for you to build ML-augmented search experience and generative AI applications without having to manage the vector database infrastructure. And Vector Engine extends OpenSearch to provide you with contextually relevant responses across billions of vectors in milliseconds by querying vector embeddings, which can be combined with text-based keywords in a single query. And last but not least, just to show the vector search offerings on AWS, we already talked about OpenSearch and OpenSearch Serverless. If you're dealing primarily with relational data, notice that you can use PG Vector extension with Postgres on both Amazon Aurora as well as Amazon RDS. And on the right, Amazon Document DB, a document database, also announced vector search capabilities. DynamoDB has a zero ETL integration, which was again announced at reInvent. So it has zero ETL integration with OpenSearch. So with that integration, you can again take advantage of vector search on OpenSearch. You can use vector search on MemoryDB for Redis for in-memory use cases. Similarly for Amazon Neptune for graph use cases. And with that, I'm going to turn it back over to AJ.
Awesome. Thank you. I will resume my screen share. And if I could get a quick thumbs up. All right. Joe, it's all yours.
Thanks. Yeah, thanks, Satya, for that high-level overview of how all the things work together. I'm going to give you some insight in how Airbyte fits into all of this, into this new AI ecosystem. So Airbyte is a data integration tool, which means it will move data from some source A to some destination B. In most cases, the sources are things like third-party service APIs or databases like Postgres, and the destinations are commonly warehouses or data lakes where you can move your data to have it in a safe place, and then you can have downstream processing and transformation of the data to make it actually useful, to extract some value out of it. And Airbyte's advantage is that it's open source software, which means there is an active community around building and maintaining these connectors. And because of that, there's a large breadth of connectors. So there's more than 300 connectors on sources and destinations supported, and you can move data from any source to any destination. So that's what Airbyte is abstracting over, and those are the problems Airbyte is solving in one place, because they always pop up when moving data from some source to some destination. You want to do incremental syncs. You want to handle changes in the schema of the source data. You want to have automated retries if some service was down or something like that. Airbyte handles all of these things for you, and it's extensible. You can build your own connectors. You can extend existing connectors. You can either run Airbyte on your own premises, completely free of charge, or you can sign up on Airbyte Cloud to have a managed service where you just need to configure your syncs, and then everything will be run for you. Next slide, please. All right, so especially when thinking about the AI space, we need to talk about structured and unstructured data. This is not really a binary thing. There's not structured data and there's unstructured data. It's more of a spectrum of data. Structured data means that the data you receive from your source, when talking about the source and destination in Airbyte terms, will be always in the same shape. So they will be the same fields, they will have the same types, and it's very clear what each value means in the data you're transferring. For example, the database table is a very good example for this. You have your columns, you have your rows, you have clear types, everything is neat and tidy. Then there's something where you have some structure, but it's not as structured. For example, log lines, they have a structure, they always have a date, they have severity, but the syntax isn't always 100% clear, and sometimes they don't follow these rules strictly. And then there's completely unstructured data, for example, Word documents, PDFs, and so on, which are originally meant for human consumption. So you can't really query them using a SQL query or something like this. But with the recent advances in language model technology and foundational models, this is now also data you can process using automated systems, and that's where all of these where this whole new ecosystem becomes valuable. For Airbyte, it's not that big of a difference moving structured or unstructured data. We always move data from some source to some destination, and this works relatively the same way for structured and unstructured. Next slide, please. So in terms of unstructured document sources, Airbyte is supporting commonly used document stores like Google Drive or S3, and we're currently working on a SharePoint and OneDrive support. And what you can do in Airbyte here is to connect to your document store, and then Airbyte can extract documents like PDF files or Word files, and it can extract the text from these and turn them into a markdown representation and send that to your destination, where it can be picked up by language models to leverage this information. Besides these document file type sources, we also support APIs that have these like loosely structured data types. For example, Slack has threads and channels and so on, but the actual value, the actual information you care about is in the messages, and it's just written from humans for humans. So there's no inherent structure into it, but by just having this raw text in your warehouse, you can use language models like offered by AWS Bedrock to get interesting insights out of it, as we will see in AJ's demo in a second. Next slide, please. So that's the source side, the A source. Now we're moving this to some destination, right? And in the case of AI applications, these destinations are often not warehouses or data lakes, at least not eventually, like when we're arriving at the final destination, but they are the vector databases Satya told us about. Airbyte supports a number of vector stores as their destinations, so you can move data from the sources we talked about to these vector databases where they can be accessed by language model applications. And it's also supporting some necessary lightweight transformations along the way, like splitting up large records into chunks that fit the embedding model you're using, and also embedding the data in transit before it arrives in the vector database. For all of this, you get the benefits of the Airbyte abstractions basically for free. So in that case, for example, Airbyte will take care of incrementally updating your data in your vector search database. So you won't have stale information in there. If something changes in the source, it will be transferred to the destination, and you will only have the updated version there. Next slide, please. So like on a very high level, this is all there's happening, right? That's the data flow. You have your relevant information in a bunch of different sources. Some are structured, some are unstructured, but Airbyte can move them all into your knowledge base or your vector database. And this is where the language model can access this information as well. And the user has some kind of UI, most commonly a chat UI, to access this information as well. Next slide, please. However, this is simplified, and AJ will go into detail why this is often too simple of a mental model. And that's where ELTP comes into play.
Awesome. So yeah, as Joe just mentioned, the ELTP model is going to be helpful for you as you're building pipelines. And we'll talk about that just to give you an overview of what we're going to demo right now and kind of how you can think of each piece. So if you've never heard of ETL before, now you have. It stands for extract, transform, and load, the ETL. And many years ago, I don't know, 10 plus years ago, we started doing ELT. And specifically, this is just a more scalable design pattern, because the fragile part of this process is the transforms. The volatile part of this is the transforms. If your business logic changes, it changes in the transform layer. So a solid extract and load is what Airbyte excels at, and basically getting your data from anywhere to anywhere so you can then transform it. And in order to really think about this problem holistically, especially for AI use cases, we need to add one more piece, which is a publish step. So the publish step thinks about not only, okay, well, we transformed our data, great, but where does it need to go? Who needs to use it? What's the best place for those users to use that transformed data? and or a downstream application to use that data. And that's what we're going to be doing today with the AI use case. We're going to be publishing to Bedrock so that the AI application can take advantage of our data. So here's actually the flow that we're going to go through. We're actually, I misstated. There is a more advanced version of this flow where we would have a final publish step to S3, but this is going to be nice and simple in today's example. Bedrock is going to take care of our transform and publish for us, and we're really just going to extract and load the data to S3. But you can imagine a more complicated pipeline where on the left-hand side, if you were at our last webinar where we transformed Notion data and made that usable for an AI, that whole transform step that was in DBT or could be in any language of your choosing could land with the final publish step to here. And then these things can be changed, which I'll talk about in a second. So here's the quick overview. Airbyte will also show you how to set this up. And also with the transform part within Bedrock. And the publish step here is just, it's entirely handled by Bedrock, so you don't even have to think about it. But it publishes to OpenSearch serverless, which is, again, within your AWS account. But it could publish to Pinecone or other sources if you preferred those vector stores. And finally, it's doing this so that a chat AI can use this data to give great answers to your questions. So just want to make this quick note about how you can chain together ELT pipelines. So this can be a robust model, like I mentioned a second ago. And sometimes you can skip steps. So if you're publishing data exactly where this next pipeline needs it, well, this next pipeline doesn't need to extract and load. So just don't think of it as a very rigid pattern. Think of it as a paradigm you can fit your pretty much any any data pipeline or AI pipeline into this model. And with that, I need to drop my share and reshare so that you can see my full browser. And we'll jump into the demo in a second. All right. So we're going to start with a quick extract and load tutorial. So we're going to go to our Airbyte workspace. If you're new to Airbyte, Airbyte has two major components, sources and destinations, and those combine together to make connections. So we're going to make a new connection. We're going to set up a new source. Our source is going to be Google Drive. And this is going to showcase the unstructured data source that Joe was just talking about. But you can imagine the same pipeline or similar pipeline being built with any of, I think we're at 300 or more possible data sources. We're going to make a Tech Guru API, a Tech Guru AI. So this is our tech specs tech spec documents, and we're going to create an AI that can answer questions from our documents. In order to do this, I need to get a folder URL, and I will get that, should be in the format like this. So you can see, I'm just going to pop over to Google Drive real quick. Here's my folder, and I'm going to get the share link, or just, I guess I can just copy it from here. If you copy it from here, there's a couple extra bits here I'll actually want to delete. And if you don't delete them, you'll kind of get prompted to do so. But here's the URL I want. I'm going to paste it in here. And I can authenticate with OAuth. Makes this nice and easy. All right, so I've authenticated. I've provided my drive URL, and I'm going to go ahead and set up the source. So notice I don't need to bring coding into this environment. If you really want code, or if you really want an infrastructure as code environment, you can do all of this with Terraform or with our Airbyte API, but you don't have to if you don't want to. So that's, I think, an important part of making this easy and accessible for everyone. And
actually, real quick, I think you need to set up the stream.
Yeah, thank you. And is that, where am I missing that? Oh, add streams. Okay, sorry. Thank you. So I did get an error message, and it says no streams are available. great. Telling me what Joe tried to tell me ahead of time, but here we go. And I'm going to set up the document file type format. Parsing can be auto, and give this a name, tech specs, or actually we'll make it easier without special characters. And I think that's all I need. Joe, does this look right to you?
Yeah.
Yeah. Okay, cool. So we will try this one more time. And once that's done, I'll be setting up the S3 destination. We also, as Joe mentioned, have a variety of vector store destinations. We do not yet have an OpenSearch native destination, but if you're willing to contribute that, or if you're interested, reach out to us for sure. We're adding new vector store destinations all the time. In this case, we don't need to send directly because we have Bedrock, and it can pick up anything we can land in S3. So I'm going to set up that new destination. I, again, could use Pinecone or any other vector database, but I'm going to go with Bedrock. Keep this, go with S3. Keep this in our AWS cloud. I'll just quickly enter the S3 information here, the bucket name, the bucket path. We'll call this tech specs. And bucket region is US East 1. And I think we need to authenticate. Where's I'm missing the output format CSV. Here we go. It's under So under S3 key ID, I'll just quickly put my information. All right, and we will set this up. All right, now this will create basically a connection from that Google Drive folder to S3, and we can configure it after we are done. It looks like tests have just passed, which is great. And it's going to go ahead and start fetching the schema from our source. This same process we're going through is identical regardless of where you want to pull data from and where you want to land it to. The only difference is what fields you need to configure per source and also per destination. Okay, so we give this a name. We call this extract load tech specs. And we can say this can be scheduled, or we can say manual or cron. We're going to just go with manual right now. And I can see that I identified this one stream called tech specs. Here I can specify if I want incremental processing and or full refresh each time. For right now, we'll do incremental. Okay, this will go ahead now and start the sync, and we'll switch over to Bedrock, where we will set up the knowledge base and agents. If there are any questions or if there's anything in the chat that I need to respond to, Joe, you can just call me out. It's hard to see the chat window at the same time as I'm presenting. Thanks.
Yeah, all good.
Okay. All right. So now while this is running, we're going over to Bedrock. And if you've not seen Bedrock before, this is the experience. I will expand my font size a little bit so that it's easy for people to see. And we're going to start off by setting up a knowledge base. So we're going to go to the knowledge base. We're going to create a new knowledge base. I'm going to use, let's call this the tech guru or tech specs. Let's call it tech specs knowledge base. And we're going to go with all the defaults here, just for in the interest of time. So it's going to set up default permissions for us. And our data source will be, we'll call this tech specs data source. And the S3 URI is I can actually use the UI here to find it quickly. Oops, wrong button. There you go. So we want to use this bucket that we've already created. And we'll just go and select that. Let me try one time. There we go. Cool. So we are setting up this S3 source for the data source. And for the advanced settings, we're just going to ignore this, again, using default KMS key. Just want to call out that this does the chunking for us. If you're used to RAG applications, chunking is basically taking a big text document and breaking it up into smaller ones. And we can go from here. All right, the vector store. This is part of the knowledge base configuration. We can select an embeddings model and choose to either create a new vector store or use a vector store we've already created. This is the easiest option. This is the option we'll do. Bedrock is going to automatically create a new open source serverless vector store. So don't worry if you've never used it before and don't know how to configure it. It'll all just be set up for us. Alternatively, if we wanted to use bring your own vector store, we could do that as well. And you can see some of the options of those are here. So we'll just use the defaults. And yeah, so I'm on the final confirmation screen. I'll go ahead and create the knowledge base. While that is running, I'm going to switch back over to S3. And actually, I'll switch back over to my Airbyte demo workspace and see how the sync is going. It looks like it is complete 3 minutes ago. So that should mean we have data in S3. Let's see if we can confirm that. No objects, refresh. Here we go. And text specs folder exists, and we have a CSV containing the text of all of our documents. You could land data here however you want. In this case, these are separate. Each document is a separate row within the CSV. And so that makes it available for the knowledge base. So if I go back now to Bedrock, I can see a status update here. Amazon OpenSearch Vector Store database is ready. And we're still creating the knowledge base. So all going well so far. Once this completes, and actually as this is completing, we can open up agents and start working on the agent. So yep, looks like it has completed. It's telling us to sync the data, start testing. So let's just go ahead and do that. And while that's running, we're going to go to the agents tab. So as Satya explained, agents are really the AI version, the AI part of this pipeline. So they are going to be able to answer our questions. They will be able to use the knowledge base as a source of information and provide an interactive experience for us to get our questions answered. Similar to ChatGPT, but entirely, again, in your own cloud. So I'm going to call this agent name, we're going to call it AI Tech Guru. Agent description, we're going to skip in the interest of time. Let's say, yes, the user can provide input. We'll just take the defaults here. We're, again, going to accept the default permissions setup, and a new service role will be created for this. And we'll just push next. Now, this is kind of fun part. You can select different models here, depending on what you have access to. We're going to use Claude V2 for this. So here we go. Oh, instructions for the agent. Right. You are a helpful AI chatbot who is knowledgeable in a number of areas. You will use a tech spec library to help answer questions. It's always a good idea to say, please don't answer a question if you aren't sure of the answer. So, of course, you can, if you're used to instructing AI, you'll have your own kind of best practices on what instructions you want to give. And this is a learning, it's a kind of iterative experience. So don't feel like you have to get it right the first time. All right, action groups, we're going to skip these, but this allows you to perform let your AI perform external actions using an API schema to execute a custom action. All right, knowledge base. This is where we get to use our TechSpecs KB. And we'll just give it a quick description. This is a knowledge base of helpful documents, helpful technical documents. Please use this for answering questions. Next. And I do want to note that on that previous screen, you have the option to add multiple knowledge bases with different descriptions. So I could have one knowledge base of all of my internal should not leave my cloud data sets. And I could have another knowledge base that's linked to, let's say, Pinecone or another application that has a different vector store backend. So this all looks good. I'm going to go ahead and create the agent. I see people are dropping questions in chat, and that's awesome. If you have questions, feel free to drop in the questions tab or into chat. All right, so this is nearing the end of our demo, and we have about 10 minutes left, so we might go a little bit late on our time, but we're getting to the end here. So we have our knowledge base. I'm going to check in on the sync before I start to test it. We have our agent, which is connected to the knowledge base. The agent now has access to our tech spec documents and any other data that we've loaded into the knowledge bases or the vector stores that we've plugged it into. And let's just quickly check. It looks like our status is ready. And just for interest of the demo, I'm going to click on the data source name and show you the interface here. I'm also going to we have a test knowledge base option you have here. The UI is really helpful for you to test everything's working. We can also go over to OpenSearch and see the index that was created for us in OpenSearch. So I think that we can. Or am I missing it? Do I need to refresh? Oh, right, it's serverless. That's right. So there's the managed clusters and serverless. We created the serverless version, which is great for our use case. And we can see that the latest to be created here is I believe this one. This is today's version. And I can see the indexes that are created here. And I can see the data that's within them if I want to. So just want to show you that this exists and you can take advantage of it. Now going back to Bedrock, we can ask questions of our agent. We can say, hello, tech guru, what is ELTP? And if all goes well with everything, then I would get a good answer. It looks like I did not get an answer to this. Let's see what happened. We can helpfully debug this question answer flow and see what happened. It looks like it didn't use the knowledge base. Jump in, Satya, if I did something wrong. Oh, maybe I was too aggressive in my don't answer a question you don't know the answer to. Let me try asking a different way. Please use your tech specs to tell me what ELTP means. I gave it a slightly different prompt than I did in my testing, so sorry if I was over aggressive on that. I'm going to, in the interest of time, switch over to the other demo that I did create and just show you how it is supposed to work if I was not aggressive in telling it not to answer questions it didn't know. What does ELTP mean? Sorry for the hiccup in this demo. It wouldn't be a live demo without some kind of hiccup. While this is running, oh gosh. What are unstructured data sources? Yeah, love the unexpected hiccups. But what I want to add here Aside from using this test interaction, you can also plug this into other tools like LangChain. We won't do that demo today, but I just want to call that out. Hopefully this walkthrough was helpful, and you can feed any data you want into the agent. And again, whether you're comfortable with external services or you want to keep it all within the AWS cloud, either way works great with this model. And here we did get a good answer. Let's see what the source is. Perfect. It's using our raw data to answer this question, and that's what we expected. So yay. It is nice that by default, the link to the raw data is provided. So if we had provided this, like let's say we'd loaded our data from Notion and put it in Pinecone or another source, we'd similarly get a link here, which is especially helpful the more knowledge bases you start to hook up. All right, I'm going to switch back to the slides, and I'll let Joe take from here.
Yeah, thanks, AJ. Great demo. Yeah, it really shows how the whole flow can work. Like you get your data from where it actually is, and then you can just connect different tools to get to a chatbot that knows like the proprietary information that's within your companies. It's not just a trained model; it can access almost real-time information that way. So this is what's possible today, but of course, development in that area doesn't stop. Everybody's committed to cater to the use cases of this new AI ecosystem. And what we're currently working on is just the breadth of its supported integrations. So Airbyte's strength with moving data from any place to any place. So we're working on different sources that are relevant in that space. I already mentioned SharePoint and OneDrive. We're also working on supporting the same thing for SFTP sources. If you have any specific requests there for some sources you want to connect, then feel free to drop a connector request. We are also working on the other side on supporting more destinations. S3 is a pretty nice common denominator to put your data, so some other tool can take it from there. But we're also working on direct integrations with destinations like Pinecone or AstraDB. A little bit orthogonal to these like pure source and destinations. Another thing we're looking into is transferring the source metadata from these sources to the destination as well to make them available to the language models. Everybody needs to know how data is structured in the source, and providing that information to the language model can help a lot, making help the language model using that data in the correct way and interpreting the data in the correct way if it knows how different types of data, for example, are connected to each other. And the other thing we're working on, which is especially important in early phases of the project when you're iterating quickly, is a deeper integration with Python-based workflows. So you can run things from within your Python script or Python notebook. We will have more to show there early 2024, so stay tuned for that. In general, for all of this, this is a very fast-moving ecosystem, and we are very interested in how people are actually using this because it changes basically every week. So if you have some needs or some questions you don't see fulfilled yet and that maybe didn't get answered in this talk, then feel free to reach out. We'll also send around an email after this talk. And this is not about selling anything. It's really just about learning and making sure we're building the right tools to make you succeed in this whole AI ecosystem.
So I want to call out a couple questions and also invite you now. Last chance, if you do have any questions, go ahead and drop them into the chat, and we'll jump on them real quick. If you do have to leave, we totally understand. It's 9:40. It's right at our 45-minute time. But if you have a few more minutes, we'll dive into some questions. So there's a question of, do we have an integration with Confluence? And Joe put into chat that we do have a Confluence source, so you can get data from Confluence. We have, maybe if somebody could, Joe did provide a link to our list of sources. I think if we remove Confluence from that link, you'll get a list of all the sources in case you're interested in checking your favorite source. I think there's another question about with Bedrock, does it only pull from S3? And I think the answer from Satya was yes for now. It doesn't mean it's the only way you can get data into Bedrock. It's just, I think right now, the only ingestion source for the Bedrock knowledge base. If you want to load the vector store yourself using Airbyte or any other tool, as we mentioned, we already support vector stores. So you could bring your knowledge base to, or bring your vector store to this ecosystem if you have one already that you're populating. Checking for other questions. Can you access Bedrock knowledge base via some API from outside service to get responses from the model? So I will take a stab at this, and then Satya, if you could jump in if you have additional information. I know that Bedrock, actually, I do have this screen ready because I knew I was expecting this question. I do know that LangChain, for instance, does support Bedrock. Hopefully you can see my screen right now. And I'll drop this link real quick into the chat. So do you want to speak more, Satya, about how folks are getting data into, interacting with the AI via other either APIs or tools?
Yeah. I'm not sure about API integration with knowledge base. I'll need to get back. I'll need to get back to you. Feel free to shoot me an email, Andre. But in terms of you can use the agent. That is one approach you can do it. Or the other would be you prompt engineer yourself. So you can build the prompt, and via API you can interact with the large language model or foundation model on Bedrock.
All right. Any other questions? I think somebody mentioned, asked about Databricks. Airbyte does support Databricks if you are a Databricks user. And could Bedrock knowledge base use Snowflake as well? We have done demos in previous where we use Snowflake for transformations and we publish it to a vector store. So that same ELTP pipeline, you just replace the publish step at the end for basically, instead of publishing to Pinecone, I think was our example, you could publish in one of two ways. You could publish to S3 like we did in today's example, or in the future when we do have a maybe a native open search vector store destinations, you could in that case load directly to the open source knowledge base. I mean, sorry, open source vectors, open search vector store. Tripping on my words there. Sorry. I think that's all the questions. So I do want to say thank you to everyone. If you do get a message from us in your email, that is us as humans reaching out to you as humans, trying to figure out how we can make the product better and what you think about the product. So we love your feedback. If you want to drop notes in Slack or send emails, we welcome that as well. And thank you all for being part of this. It is almost the new year, so we will see you in 2024. A huge thanks to Satya for being here with us. We're so grateful and excited for these products on the AWS side. So yeah, everyone have a great new year.
Thanks, everyone. Thanks for having me. And just to close out, Andre, to your question, you can use the Retrieve API for knowledge base. I just dropped the link there. So, and if you have any further questions, feel free to reach out to us.
Fantastic. Thanks, everyone.
Thank you. Bye.